Not much to talk about today. Friday we're going to go over the paper. I should have everybody's stuff graded by then. So I really only have one reminder, right? We're having a chiller week. Fallon is running her test review session. Please let me have that time right, because I already told them the morning class. And tomorrow at 6. So remember, this is the review session where she's going to go over the test. So the first half of the session will be focused on how to do a test. And this is sort of generally, right? How to break down questions, how to look at questions, and then how to sort of sift through answers and narrow them down and choose the best answer. The second half-ish, half is a very general term, will be focused on actually opening up the exam and looking at some select questions. So what you should do before you come is remember that for at least all our tests, you can go in and actually look at the exam. So you should look at exam 1 and outside of your actual score, which hopefully everyone has at least looked at this point, is you can click into it and review your actual test. So see the questions, what you answered, and what the actual correct answer was. So make sure that you review that, and it will be a good opportunity for this review session. Keep in mind, this is one of the SWOT requirements. So if you're in SWOT, you need to go to this. It's open to everybody, and I highly recommend it. This is one of the few remaining non-content review sessions. We'll also have one for the paper as we get talking about that. Also, please keep in mind that if you cannot come on time to these things, it's okay to show up late, right? And since you don't have to have your camera on, it's okay if you're a hot mess as well. No one can see you anyway. But it's just really important that you come to these resources that we have available. Nope, I just really have a bad habit of that. Okay. So we left off at the very end of class. We had just gone through our roadmap. And now we're looking at summarizing what is it that we want to do as we go through the goals of cellular respiration. Okay? Remember that our big goal here in general is to get some kind of energy out of glucose, or a large organic molecule. So remember, okay, when we use the term organic molecule, okay, we mean a carbon-based molecule. Okay. So some kind of molecule that has a bunch of carbons in it, and our goal is going to be to break those bonds between those carbons, and we're going to get energy out when we do that. So as we're breaking those carbon bonds, and we know that we can associate these very familiar terms, okay, from our last unit. So remember, catabolic, okay, is the metabolic pathway. Okay, the cat, and it has stopped now, but okay, the cat knocking things down, breaking them, and we get energy out. Okay, exergonic, remember, focusing to the energy, so we want to think energy exits. So these are the terms that we know are going to apply to the process that we're doing. Okay, so as we think about this, and cellular respiration in general, there's two major groups, or two major ways in which we can do this. Okay, the first of which is called aerobic. Think like aerated coffee. Okay, so this is still going to use our organic, right, our carbon-based molecule, okay, but it's going to also use oxygen. Okay. That's what they're doing to your coffee or your yard, and they're aerating it, right? They're adding oxygen to it. So this is a much longer process. This is the one that we started to talk about in lab, but never quite finished, right? Because it takes so long to get through. Okay. So the disadvantage is that it is a much longer process. It's a lot more complicated. But the benefit is, dollar bills, yo. Okay, it's significantly more efficient. We get a lot more bang for our buck when we're going through the aerobic process. We get lots and lots of ATP. And I know we didn't get there in lab, right? We were doing cellular respiration light. You'll see when we get there here, okay, that it really turns it out. Now the other option is called anaerobic. And you'll experience this prefix a lot, okay? The prefix an or a just means without. So in this case, literally just without oxygen. So we're still going to start, we're still going to start with that organic molecule. Our goal is, right, to still break a sugar molecule. We're still going to get some energy. On screen? Yeah. Okay. It's going to be less. Okay. So while this is quicker, there's less to it. We don't need as much. Okay. Our repercussions are going to be, we don't get as much out of the deal either. We don't get paid as much for doing it. So we're going to compare these processes over the course of our conversation in this unit. Okay, with me so far? Feel good? All right, so here's our overarching goal. When you're doing cellular respiration, you can be aerobic or anaerobic. No. You can have the oxygen process or the no oxygen process. Either way will get you breaking down an organic, right, carbon-based, and give you ATP. Remember, when we think about cell fuel, okay, we want to think about the goal here being ATP. Right? This is what the cells use to do work. So whatever we're bringing into the cell that has energy in it, we need to convert that to ATP. And that's the big goal here. One way or the other, okay, we need to get to ATP. Because we can't use sugar or proteins or anything else to drive those transport vesicles. They have to use ATP, right? You can't stick a donut in your car. It has to be gas. Okay, so that's our problem here. How do we get ATP? So we're going to start with glucose, with sugar, okay, and follow a series of steps to get to that ATP. Let's use this head fish. Okay. General summary, feel pretty good? right, so we're going to review this roadmap a lot over the course of our conversation, so don't let it sort of overwhelm you right now. We're going to take it in bits. Okay? So we're going to both have our written roadmap, right, the one that I have up that takes us through our steps. And we're going to have this visual roadmap that lets us know where in the cell are we and what are we doing. So we have lots of resources. So as we look at this, there's actually a lot of familiar territory on here. We just don't really realize it. So we've done glycolysis, prep step, and at least part of the citric acid cycle, right? We did those in lab. Okay. So all this is doing is outlining for us where in the cell are we, okay? And to some degree, although it's missing some pieces, but what are some major pieces? So am I getting ATP? And am I getting some of those electron carriers? It's not super thorough, but it's giving us a baby snapshot. And we know that we have steps 4 and steps 5, which you guys have not done. And that we know, or at least we better get ATP from that. Otherwise, what are we doing? Right? Okay. So let's go back to our roadmap. Okay, so we're ready to dig in and start glycolysis. So remember, as we look at this, we have several questions that we want to answer along the way. We know when I ask these questions that they're probably going to make up our in-class activity. So we want to keep track of what's the big goal. Okay, so what's the overarching point of this particular step? Okay. Where in the cell am I? Do I need any form of oxygen? And am I making ATP or any other kind of high energy product? Okay. So we're going to work together and make sure that we answer all of these questions. Okay, so we're going to start keeping tallies at the back of our head for each of the steps that we go through. And this is going to help us, as we find at the very end, have a really good way to summarize what we've gone through on our very long journey. 5 steps. I forgot how to count 5. All right, let's hit it. Okay, so the overall goal, question 1, of glycolysis is to bust down glucose. We're going to tackle the biggest of all our molecules. And this tells us that right in the name. Okay. So, the first part of the word, glyco, looks a lot like the word glucose. Oh, heavens to Betsy. There we go. AKA our big sugar molecule. This one. Okay. The back part here, lysis, now that's a segment we've seen before, right? Like hydrolysis or lysosome. We've encountered this several times. So we know that this means a break. So the word is telling us we're going to break glucose. And that's exactly where we're starting. Okay, glucose. A large 6-carbon sugar. And we know it has to have carbons, right? Because we know we need to have an organic molecule. 1, 2, 3, 4, 5, 6 carbons. And then we have blah, 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 some process. The end goal, pyruvate. Now, pyruvate only has 3 carbons. And so we know we've busted it up, but we do have a problem. Okay, our laws of thermodynamics and conservation of matter, right? That specifically says that you can't make stuff disappear. Okay, so we can't make 3 carbons just disappear in this process. Okay, so if I have a final result of pyruvate that is 3 carbons big, but I started with 6 carbons, I still have to have a total of 6 carbons. Right? 3 carbons can't have just disappeared into the ether of the universe. So I have 1 pyruvate made of 3 carbons. I have 2 pyruvates. Okay. So grand total, I still have 1, 2, 3, 4, 5, 6 carbons total. Yay! Okay. So we haven't done any alchemy. I still have the 6 carbons I started with. I just end up with 2 smaller molecules that add up to the 6. It's like busting a Kit Kat bar in half. Still have the whole Kit Kat bar, just been busted in half. Also, now I'm hungry. I'll need some Kit Kat. Okay, so this is our big goal. I turn 1 glucose into 2 pyruvate. And we're going to make sure that we count these carbons, okay, so we don't perform magic tricks. Feel good with me so far? All right, so let's see how this is done. Here we are, doing some glycolysis. Here's our visual roadmap. One of these days, I'll get the hang of that. All right, so here's this big structure. This is the mitochondria. Poor little glycolysis looks a little left out of the mitochondria. So where is glycolysis? Cytoplasm it is. Right? So glycolysis is not taking place in the mitochondria, and it's not being shown in any other organelle. So it's being all alone, left out in the cold. Okay? This is going to be one of our only steps that takes place outside. Okay, so now we've answered another question. Where are we? We're in the cytoplasm. Thank you, oddly shaped figure. We also know from this figure that we're going to get a little ATP, but we're going to go into more detail with that. Okay, so we have 2 of our answers figured already, right? Our goal is to get our glucose into 2 pyruvates, and we're sitting in the cytoplasm as we do it. So let's look at how exactly this is going to happen and see if we can pick up most of our other questions along the way. So glycolysis happens in 2 phases. first phase, I was going to do it again. I just don't learn. It's called the energy investment phase. So we think about this whole process being a catabolic reaction. It's a bit like getting over that activation energy, right? We have to put a little into it to get it started. The way we're going to do that this time, okay, is to actually invest a little bit of ATP. I like to think about this like buying a lottery ticket. Okay? Regardless of what happens with that lottery ticket, you have to pay for that ticket up front. Right, so I paid 2 ATP. Before anything else happens, -2 ATP. Right, out of my pocket. Bummer. Right, now, the benefit of this, despite the fact that we've now dropped 2 ATP, is we can now start breaking down that big 6-carbon glucose. Whew. And so we're on our way. We're getting over that activation energy. We can start going. We start this process moving. Okay? So far? Now we can get to the hot ticket express, energy payoff phase. Someone slide in. Okay. As the name implies, okay, this is where we get all our winnings. Okay, so I get my lottery ticket, I scratch it off, okay, I win 4 ATP, $4. Luckier than any lottery ticket I ever got, I tell you that. The other thing that I got here are 2 NADH. Okay. Remember, this is not directly energy. So I'm going to call these coupons. Okay, here's why. So we haven't talked about these in a while. There are 2 types of what we call electron carriers. One that we won't see for a while. So we have NADH and FADH2. We'll encounter FADH2 in the citric acid cycle. That finally leaves the electron symbol. Okay, so electron carriers are high energy products that we're going to use in the final 2 steps of cellular respiration. So I know you've been kind of going on faith that they actually do things since we keep just not getting there. What they're going to end up doing is allowing us to cheat and do active transport without paying any ATP. Sort of a big deal, right? Because that's not something you can normally do. So these are going to work as coupons for active transport. That's a pretty serious coupon. Okay, so every time we get these, we're going to put them in our piggy bank. We're going to want to collect them. And then we're going to cash them in all at once at the end. Okay. The electrons, because the active transport, we're going to do at the end, are protons. That's how it works. Coupon system. So for now, just trust me. We're going to piggy bank them. Okay, make sense? Okay, so we won $4 for ATP and 2 coupons. Okay, just like real coupons, right? Not actually money. Okay, but if you use them right, they do have value. Okay, so what did we end up with here? Okay. We have our goal at the bottom. 3 times in one slide. Really just did not learn. Okay, by converting that glucose into 2 pyruvate, and making sure we still have 6 carbons. And note that we ended up with 2 ATP. All right, I started out by spending ATP. So even though I won $4, it cost me $2 in the first place. I bought that lottery ticket, right? So in the end, I only ended up with netting. I only got to keep $2 total. So I had to pay back that debt. Right, so kept $2, 2 ATP. It's still not 0, right? 2 is low, but it's not 0. And lastly, okay, we have 2 coupons. So we're going to put in our piggy bank, save for later. So we didn't exactly make bank, but we're not sitting at 0 either, right? It's most assuredly a C. Okay, any questions about the process of glycolysis, any of the steps or phases that we did, and any of the prizes that we won? Someone in the last class asked a great question about this water that came off here. Where did that water come from? Yeah, so we're losing it from breaking bonds. And this is part of that second law of thermodynamics, right? We're losing some of its energy. We don't get to keep everything. Right? So chaos and all of that. Good job. Big slide. Okay, so let's make sure that we've summarized everything that we've gained here. Okay, so remember our goal. Right, we have our time then. Our goal is to take glucose. Right, we have our 2 phases and broke it into 2 pyruvates. Okay, and in the end, we made 2 ATP. Next, we got a little something out of the deal. Okay. This is the first step before major respiration processes. Now, the key here is everything we just talked about. Did we talk about oxygen? No, right? So this is not a step that requires oxygen. Okay. This is a way that we can get ATP anaerobically. And I need a ton, but again, 2 is not 0. Okay, now more importantly, for the conversation we're having, is we still have organic molecule, right? We still got pyruvate. We got some carbons. Okay, so if I focus here, in between those 3 carbons, I still have bonds. I still have bonds. I can still break those bonds. And if I can still break those bonds, I can still get energy out. Okay? So I can still squeeze something out of those pyruvates. So we're going to keep going with this. And that's what the rest of this is going to be about, is what more can I squeeze out of pyruvate? Any questions about glycolysis before we squeeze pyruvate for all it's worth? So that's a great, so her, okay, so her question is, in anaerobic respiration, what is it doing with the pyruvate? And she made a comment about holding her breath till she passed out, which is why we're giggling. So we'll talk about this a little bit very lightly at the end. But in part, yes. So if we're going to do anaerobic respiration, also called fermentation, we basically do cycle through a version of glycolysis. So we take pyruvate and we convert it to a sister product, and it loops the process. And it ends up making lactic acid, which is what makes your muscles burn. Great question, posed in a very fabulous way. a little morbid. Any other questions about glycolysis? It does, yeah. So her question is, if we're going the lactic acid or the anaerobic respiration route, do you still have to use energy to start it? And you do. So this is a more inefficient process, right? So it's hard to get a net ATP this way. Which is why, like, when you're running and it's hard to get oxygen, right, you slow down because it's hard to continue to build ATP up. Also because lactic acid hurts. Anything else? All right, let's go to menteecom. I haven't done one of these in a while. The break. So now we're going to go to menteecom. When you get there, we're going to put in the code. Our code is 4861 81 2. Okay, so we want to be thinking about, remember our goal from here on forward is squeezing every last drop from that pyruvate. Okay, so we're taking pyruvate forward. So as we go forward, how many times are we going to be doing that? Just drawing over the button that unhides it. That's very helpful. All right. Let's take a look at this. Okay, so if I have one glucose, and that's where we started. That is a 6-carbon molecule. A bunch of steps later, I end up with pyruvate. And remember, okay, no magic can happen in this classroom. So, you also need to have 6 carbons. In order to keep my 6 carbons total, right, I need to do, as 3 carbon molecules, I need to have 2 of them. 2 times 3 carbons equals 6. So I know that I have to have 2 pyruvate. Now, if I have 2 pyruvate and I have very, very efficient cells that are not going to waste anything that they have, I'm going to use all of the pyruvate that I have. If I have 2 pyruvate, I'm going to use 2 pyruvate. So everything that I do, I'm going to do to both my pyruvate. Feel good? Okay. This is a good thing to keep in track of because now that we've broken our glucose down, we're going to do a lot of things twice. And it's kind of doubling a lot of our stuff. All right, great job. All right. Any questions about any of that? You're extraordinarily quiet today. Okay, so onwards and upwards, we've finished glycolysis. We've gone from 1 glucose to 2 pyruvate. Okay, so now we're going to do something with that pyruvate. Okay, and that's something that's going to happen in the prep step. Okay, so that's step 2 of 5 now. 2 of 5. I'm not doing much with my hands today. Okay, so we want to keep our same list in our mind. Okay. We answered all these questions before. What was the goal of glycolysis? Break down glucose into pyruvate. Where did it happen? Cytoplasm. Did we need oxygen? No, we did not. Did we make ATP? We did. We made 2. Good. Did we make anything else? We made the NADH, right? Our coupons. Good. We want to keep that in the back of our head. So we're going to do the same thing for our prep step, right? We want to know what's our goal, where are we going to use any form of oxygen, and are we going to make ATP or any other energetic compounds? All right, prep step. All right, so let's start answering questions. So we see right away, okay, that we've made a move. Okay, from the cytosol, aka cytoplasm, into the mitochondria. Okay, so the prep step moves into the mitochondria. Okay, now that we've moved into the mitochondria, we will never leave. Okay, so glycolysis is the only step that occurs in the cytoplasm. Everything else, the prep step included, okay, occurs and happens inside the mitochondria. Okay. One question down. Some space here. All right, so let's look at our goal then. So we started with pyruvate. Okay, our end is what's called acetyl-CoA. Okay. The big key feature of this is this CoA bit, okay, which is fundamentally like a little flag. As we can see, there's not really a whole lot happening here. I'm not going to spend a lot of time talking about the prep step. There's not much to talk about. The whole point of the prep step, as the name implies, is to prepare it to go on to the next step. And the next step in this case being the citric acid cycle. Okay. The trouble is, as pyruvate is sitting, the citric acid cycle won't recognize it. It can't use it. Okay. So what we need to do is make it recognizable. Okay. So this CoA group acts like a little flag. See me now, take me now, you can use me now. Okay. That's really the main thing that we're doing here, is making it so we can pop it into the citric acid cycle, which we'll find on Friday, does a whole lot of really important and useful things. Sorry, prep step. No offense intended. The other thing you'll notice is how many carbons we got. Uh-oh. We got 2 carbons. Pyruvate had 3, right? 1, 2, 3 carbons. Lost one. So this is where our 3rd carbon went. Okay. So we lose 1 carbon. along the way. Acetyl-CoA is a 2-carbon compound. You lose 1 carbon along the way in the form of carbon dioxide. Where does the carbon dioxide go? Out, right? Okay, so this is one of our connections between cellular respiration and ventilation. You're going to breathe this out. Okay. Let's go ahead and stop here. We'll finish talking about the prep step and review it a little bit on Friday, because I don't want to rush through it. And we certainly can't rush through anything in the citric acid cycle.